Good afternoon. It's Friday afternoon, K 2022, and it's amazing you're here. You're spending your valuable time with Milliken, and we're very grateful for that. And welcome to the Milliken Tech Talk. This is a series of talks that Milliken is staging throughout the K Show, where we invite experts to explain why they are collaborating on initiatives that further the future of sustainability. We have two speakers this afternoon, and on my left is Ruud Rollo, and I hope I pronounced that correctly.
Almost, yes.
Almost, there you go. He's the CEO of, well, it says it all behind me. And we have on my right, we have Dr. Scott Chenna, who is a senior scientist at Milliken. So without further ado, I will ask them to give you the presentation, and then we'll see if you have any questions afterwards. Ruud.
Yes, thank you, Willem. So, thank you for the kind introduction and Milliken for having me here. So, I have a background in plastics for almost 25 years already. And in those 25 years, we have seen a great acceleration happening in plastics. The usage of plastics has been excessive. So it has brought many good things to our lives, but it also, let's say, presents a couple of challenges that we want to talk about, and those challenges can be put into opportunities. Right. So a little bit of our company. The company is called Helion Polymers. We're a sister company of Colorfab, located in Belveld, the south of the Netherlands, where we employ 40 people, all centralizing around material application development. So we formulate materials for both 3D printing, bioplastics, compounding, so all in one center. All right. So our weapon of choice for today is PHA. So we have been working on this material since a couple of years, which was originally, let's say, discovered by a Dutch scientist, which we see here on our back, Martinus Willem Beyering. And PHA is a intracellular energy reserve of microorganisms. If they consume a carbon feedstock, they can store this PHA material as an energy reserve as part in their own body, like a winter reserve. And this is the material that is fermented by those microorganisms that can be used as a plastic replacement, basically. So PHA represents a very versatile building block. We can mimic a lot of properties like high crystalline materials, amorphous rubbery materials, and even material that mimics PP. And of course, PP is a well-known material for Milliken. Okay. So PHA is intrinsically biodegradable. It acts as an energy reserve for microorganisms. So PHA is readily metabolizable by microorganisms. So it's a nutrient that they can digest in many environments, in land, in soil, but even in sea or fresh water. So, with all this knowledge, we started a new initiative called Pharadox 2 years ago to explore new opportunities for a growing portfolio of PHA building blocks. So, this is called Pharadox. It's a brand name of Helion Polymers. And we decided to build a complete new business model around PHA. We have been working for it with PHA for 15 years, but we thought the time is now to make a big step. So after, let's say, working on a new business plan for at least 1 year, we decided to phase out all fossil-based activities and centralize the new business model fully around PHA. Working on R&D, application development, production of compounded formulations. We distribute raw materials, and in order to be successful in those revenue models, we believe we need to share knowledge. We need to teach converters. We need to work together with brand owners to make, let's say, the application successful. PHA is not an easy material, so we need to find partners, partners like GoPHA, partners like PHA building block producers. There are not many, but if we collaborate, we can successfully convert certain building blocks into real-time application. And this is also where Milliken comes in to contribute to make, let's say, PHA processable. Right, so we started about 2 years, 3 years ago with our first steps on lab scale, how to process PHAs, um, run a variety of formulations, and ultimately scale up to pilot scale. Once again, also working with Milliken to make the materials processable. And we succeeded in rolling out a couple of applications in injection molding and 3D printing, and more recently also extrusion blow molding. Those can be beverage containers or containers for shampoo, personal care products. And I think this is a nice bridge also to the product portfolio where Milliken is active. So come have a look at our website, pharadox.com. You can download a lot of information there. And then I'll leave it up to you, Scott.
Thanks.
Thank you.
And thanks again for everyone to be here, especially with the looking outside. It's sunny. It's so beautiful outside. Anyways, so we at Milliken have a long history of sustainability and collaboration across the supply chain to get to more sustainable solutions. For those of you who are not familiar with us, we have about 8,000 people worldwide. We're privately held. We were founded in 1865. And, we were doing the math as part of another talk. Our first recycling policy was in 1902. So we're celebrating the 120th anniversary of our first recycling policy. So, well before recycling was probably even a word, right? So, if you look at where we are from a corporate perspective, we have a purpose to positively impact the world around us for generations to come. And a lot of that comes from being privately held and held by multiple generations of the Milliken family. A couple years ago, we put behind that purpose our sustainability efforts to really look at people, products, and planets. So the people is really caring for our communities, making sure our customers and our associates are safe. Product around circularity and advancing well-being, and that's very well where the PHA projects and the PHA collaborations fit. And then planet, reducing our environmental footprint, also a really good fit for PHAs. And as of, I guess it was Wednesday, we had a press release with our CEO where we announced that we had our net zero targets validated by the Science Based Targets Initiative. I have a slide that will talk about that, what that means in a couple seconds. So as a testament to our sustainability efforts, we achieved the EcoVadis Gold rating that puts us in the top 7% of sustainable companies or of the companies that they rate via this process. So very high level. I think I've walked around here a little bit, and I think there are only 2 other companies that are EcoVadis Gold in this building. And more recently, I think a really big step for us, especially as a private company where we didn't really share, we don't share our financials externally, we didn't really share our environmental footprint externally, is to be very clear about our net zero goals, both short-term and long-term. So the Science Based Target Initiative, which I think is the most demanding set of validated targets, has approved our targets to reduce our scope 1 and scope 2 by 50% by 2030 and our scope 3 by 30% by 2030, and then net zero goals by 2050 with 90% reductions in scope 1, scope 2, and scope 3. And there are a number of ways we're doing that. We're doing that by changing our energy that we're using to produce materials. But then as you look across our portfolio, not so much in the chemical business, but also in the textile business, we're looking at materials that are more sustainable. So moving from PET to rPET. And then as we develop the technologies together for PHA textiles, that would be an excellent way for us to reduce our scope. So, our vision is to boost circularity and enhance plastics, very broadly plastics, right? So I think the PHA community doesn't like to be termed plastics. It's a polymer. Polymer that's molded into a final form is a plastic. So trying to understand how we can collaborate across the supply chain to advance these materials. And as a snapshot of some of the supply chain collaborations we have, a lot of them are set around circularity, collections, setting up collection systems for recyclability. I think as we move towards more compostable solutions, what we learned from recycling collection will help us in the composting to make sure that the PHAs and other biodegradable compostable materials make it in the right food in the right stream. Go PHA has been super helpful with us in this space, getting us introduced to the other folks in this group and introducing us, I think, initially. We've also published in this space. So a publication that I just had, the Polyolefin Innovations Towards Circularity and Sustainable Alternatives. That sustainable alternatives is important in this case because Eugene Chen, professor at Colorado State, has a nice section on how PHAs could take some of the polypropylene space in terms of various alternatives. So what we're doing and what our expertise is in polyolefins is around nucleation and controlling processability. And I just have one snapshot here. So this is a PHB homopolymer. And what we try to do is we try to take these materials that are finicky to process, I think is fair, and try to force them to process like polypropylene and polyolefins. So these parts were all injection molded under ISO polypropylene conditions. And without any nucleation, you can see that you got kind of an ugly surface up here in the sample number 1. You get warpage because you don't get full crystallinity and solidification in the mold. But with some of our developmental nucleators, you can see that the square parts are actually square, which is what you want, right? And as you get into more difficult geometries like screw-on caps, you want to make sure that the cap screws on and screws off, right? So a little bit of the initial work that we're doing in this space to really understand how we can benefit and grow these materials. So I think with that, yeah, so thanks. We're happy to take questions.
Thank you very much. I'm sure that you have lots of burning questions, but before you do, I just scribbled a couple down just now, and I wanted to start with you, Ruud. You said we need converters was one of the things you said. Are you talking to them, and how are they responding to you?
Yes, we do. So we both get inquiries from brand owners and converters, obviously trying to address also more sustainable products in the end. So converters can be addressed directly by brand owners, but in the end, they want to know if they can convert those new materials in the same way as they process their commodities like PP or ABS or even nylon. So can I work with this material? How it's done. So right now it's still a niche, it's a specialty trade, I would say. So they come to us to address feasibility, and which can present a couple of challenges, of course. Right? So there we come in, we compound material, and we try to educate them on processability, processing window, what settings do we use, what machine do we use in order to make them successful to convert PHA. And there we see that PHA still has a very narrow processing window, which we need to address. And this is why we collaborate, for example, with Milliken to receive a better understanding about, let's say, some specific characteristics of PHA, crystallization dynamics. How does it work? How will, let's say, understanding this process enable us to make a good product? And this is exactly what we need to teach, let's say, the converters in order for them to be successful addressing the needs of brand owners. So there's a lot of exchange necessary.
And I might add before the next question is one area that Milliken has excelled in the last couple of years is intermaterial replacement. So we have currently focused on taking somebody who uses polystyrene or a even less sustainable material and shift that to polypropylene, which can help them reduce their carbon footprint. And we're looking to take that experience and working across the supply chain with the brands, the converters, the material producers, and how we've learned to shift markets and bring that to the PHA market.
Very good.
Thank you very much indeed. Scott, I have a question for you as well, and that is, how did you get to cooperate with Helion Plastics? Is it, I mean, and maybe people out there may be wondering, how do we contact Milliken? How can we cooperate on projects? People who may have ideas. Mm-hmm. How does that work?
Yeah, so I think the Helion relationship is a great example of why we joined some of these global organizations like GoPHA. You know, the leadership, which we're fortunate enough to have here, saw the advantage of, I would say, pre-commercial collaborations between the entire supply chain and industry. And Ruud talked about the collaborating with external companies and sharing knowledge and teaching, and they've done a great job of teaching us about PHA, about how to process it, because there's a little bit of a learning curve. And then we're trying again to teach them about how we can use our nucleators together to improve processability.
Okay, so the message basically is don't be shy.
Don't be shy.
Don't be shy. All right. Thank you very much. Any questions from the audience? We'd be happy to take those, please.
Yeah, thank you for the presentation. I was just wondering, you've been doing a lot of work with PHA. Milliken works with a lot of different materials. How do you see the synergy with other material platforms like PHA, but also others? We have a joint challenge on developing circular materials, basically. So how does PHA fit in that purpose, but also with all the limitations on availability in, let's say, the coming 5 years, what sort of opportunities do you see with synergies with other materials to reach to that ambition, the higher ambition of reaching circular materials faster or differently?
Yeah. So I think, in the short term, using PHAs as modifiers for other materials that are more readily available, like PLAs, I think is an interesting area to look at. As we talk about circularity, the PHA circularity isn't necessarily the recycling circularity, right? And although there's no reason you can't collect it, break it down to its raw materials, and feed it back to bacteria and let them get fat, and kind of like us here after all the chocolate at our booth. So the biological circularity, I think, is an interesting space, especially in food packaging, flexible packaging, where it's hard to scrape out all the foods to get those recycling. And the key here is setting up those collection systems so that we can use the PHAs to take the remaining food, get that into a composting stream where we can return the minerals back to either compost or collect the gases, or use it again as a feed stream for PHAs, because there are a number of folks that are using waste materials as PHA feed streams.
All we have to do is thank you for being here and to wish you a very successful continuation of K 2022. Thank you.